Replace your print servers with a secure cloud solution that scales with you. You'll automate print management, get scalability and flexibility, as well as complete control with visibility into all your print processes. Start a free 30-day trial by going to printerlogic.com/packet pushers.
Hello, I'm Jonna Johnson, CEO of Nemertes, and I'm here with my co-host,
John Burke, CTO.
And you are listening to Heavy Strategy, the show that tries to ask the right questions, not give the right answers. And on today's show, John and I decided to talk about a conference that we recently attended, Nemertes Next, that kind of blew our minds in all sorts of different directions. And for this conference actually focuses on the next technologies, emerging technologies that are coming down the pike. It's focused, it looks a couple of years out, and it's much broader than just IT. So initially we thought, well, are our Heavy Strategies listeners going to care about what we saw at the conference? But then we talked about it and we said, listen, there were presentations and topics that are very relevant if you're in IT, either personally or professionally. In some cases, there were things that were just flat out cool, but when you thought about them a little bit longer, they also had something important to say about the work of IT and in particular, IT strategy, so technology strategy. And one of those that I think both John and I liked a lot was by a guy by the name of Luke Becker, who was the Dragonfly Mission Assurance guy Dragonfly Mission Assurance Manager at Johns Hopkins Applied Physics Lab. Basically, he is overseeing the project of getting a drone to Titan. And if you're not familiar with this, Titan is one of the moons of Saturn. And if you go way back like John and I do, you probably remember the Kurt Vonnegut book, Sirens of Titan. I do remember it. I don't remember what it was about, but I do remember the cover page on that because I read it when I was extremely young and kind of impressed by the art back in those days. So in any event, what impressed the living daylights out of me was not just that essentially we have this giant project underway to send a drone to Titan, but that this project was launched in 2019 and will not conclude until 2037, which is basically, if you can do basic math, that's like 18 freaking years.
Not for folks who need immediate gratification. Yep.
Exactly. And in IT, I mean, half the time our problem is, not only did I want it yesterday, but really you need to solve this problem by tomorrow afternoon. And I mean, there are entire companies that come and go in the space of 18 years and are long forgotten 18 years later. I mean, the cycles are so fast that I started thinking, this is almost like it's hard to believe that you can sit down and plan generational length technology projects and what goes into planning on this project. One of the things that was fascinating was the degree of complexity, because essentially they have to get a space, they have to use a rocket and they haven't decided which rocket they're using. They're in the process of looking at different options, but they're using a rocket to get the spacecraft out in space. The spacecraft then has to go all the way out to Titan, and then it pops out the little drone, which is about, I say little, but it's about the size of a car, which then will wander around on the surface of Titan and do things like analyze chemical components and processes that produce biologically relevant compounds, see if there's habitable environments, measuring the atmospheric conditions, looking at methane reservoirs, and all this fun stuff. So it's like a little roving science lab. But there's literally 3 vehicles involved. There's the spacecraft, which they are actually just, as Luke put it, they're just going to Uber. They'll find out whoever has the best spacecraft, launch with that. Then, the rocket. Then the spacecraft is one of the things they design. And then when it lands, it sort of spits out the drone, which goes wandering around on Titan. And all of that is scheduled to happen by 2037. The launch, I believe, if I'm reading this timeline right, is in I want to say 2029, but there's an Earth flyby because they're going to do like a slingshot effect. So the thing gets launched, it spins around the Earth and points itself at Titan. And then eventually, years and years and years and years later, it lands. So just all of what it takes to put in place this kind of planning, where on a scale that's just hard for us in technology to even understand, I think is fascinating. And John, I know you like this, and I've been yapping. So what were your thoughts on this?
Well, I too was struck by the length of the planning horizon there because, my timeline for long range planning in IT has degraded so steadily over my years in IT. I remember when I started, I was thinking in terms of, 10, 12 years out. And that rapidly got beaten down to 7 to 8 years out, and then further down. So a long range plan became a 5 to 7 year plan. And I know companies where the 3 to 5 year plan is now considered the long range plan. So yeah, planning for something that's still going to be in service in 2037 is pretty impressive to me. The second thing that really struck me was the fact that they don't get to actually test the critical systems on this one because they can't replicate the critical environment, which is the low gravity of Titan. It's not zero gravity, and it's not, like lunar gravity. It's something we're not familiar with, and they can't test their vehicle in it. The other thing is, and you've been saying on Titan, but it's really on and above Titan because the Gizzy flies. It's a drone that can land. So the idea is that it will hop around from place to place. After studying here, it will go study there. And it's the flying part that they can't test. They can't test flight in the low gravity, high pressure, low temperature environment that they're going to be in. So it's going to be really interesting from that perspective to watch it all come to fruition eventually.
Well, and John, I'm going to ask you, since we like to talk about asking the right questions, you could look at what Luke and his team are doing and say, what are some of the best practices that they're putting in place for a project of this length? But when I look at it, it's more like, what are the questions that they need to be asking that ultimately ensures success? And maybe this is biased slightly because Luke is the mission assurance guy, so this is his job. But the single biggest question I would say that applies to any IT project of any length, but particularly any technology project of years in duration, is what could go wrong? And one of the things that Luke spent a lot of time doing was answering questions that other people thought might go wrong. So, for example, what is the power source for this drone? Well, it's nuclear powered. Well, great. That means a whole bunch of agencies wanted to know what exactly is going to happen when they take a little piece of plutonium and slingshot it around the Earth. One thing that could go wrong is it could hit an asteroid and fall to Earth. How bad is that going to be? What's the mitigation strategy for this? And so Luke has spent a ton of time working through those scenarios and coming up with mitigation strategies. But the question, what could go wrong, is probably a great exercise for folks to ask themselves, not just internally, but sort of if you've got a big, hairy, audacious project like this, wander the halls and ask people what they think could go wrong, because you really want those off the wall observations to make you go, yeah, okay. And you may choose not to mitigate against everything or to minimally mitigate against things, because if you mitigate against absolutely everything, you never do anything. But what could go wrong is probably one of your top questions if you're doing any kind of significant project. And John, I don't know if you've got similar thoughts on good questions to ask if you can't test something.
Oh, well, yeah. I mean, testing everything you can to try and minimize the area in which you can't test. That's one thing you can do to try and minimize the risk that things won't happen. The other is testing as close to the end conditions as you can. But I think one of the key takeaways for me on the timeline was having a goal for the long project that you're confident will still make sense when the long project comes to fruition. So ask yourself, is the goal of this project still going to make sense if it takes 10 years to get there? Because if the goal is immediate competitive advantage, if you're deploying in an enterprise environment, are you confident you'll understand the competitive landscape? Are you confident your business leaders understand the competitive landscape they're going to face 10 years from now? And those are questions maybe to ask them before committing the IT's resources to that kind of a project.
If that even happens, and by the way, if you guys are actually engaged on a project that lasts more than 2 years, we'd love to hear from you because
Oh
my
yeah.
experience is the same as John's. IT projects have gone from decades to years to, months to weeks to minutes at this point, and it's all about moving fast, even if you're going in exactly the wrong direction. John, what was like your top pick or one of your top picks from the conference, either professionally or personally?
Um, Interestingly, I think my top takeaway for IT folks was a session that wasn't about technology in any way. And that was a session on storytelling by a science fiction author, Aaron Bow, um, who was talking about the power of storytelling and framing it in the sciences or the context of the sciences. How if scientists want people to understand what they're learning, what they're trying to learn, they need to be telling the story themselves, because when other people tell the stories of the sciences, they tend to either get it wrong or shape it towards their own ends rather than having it being about science. Um, and so it was an uh, extremely thought-provoking exploration of the power of storytelling as opposed to just fact telling, and the again and again hammering home the point that facts don't change minds. Facts in the context of a story change minds, and that if you don't have the right story to go with your facts can even make people double down on their incorrect story about what's going on. They can drive resistance to learning new facts if they're not embedded in a story that competes well with the story that somebody's already got in their head. And, she had many examples of that, mostly in the context of politics, but certainly in the context of the sciences. You could pull similar things from the history of science going back, especially into the Soviet era in science, and Lysenkoism and things like that. Look it up, folks. It's a ton of fun.
John's background is in the history of science. So when he says it's a ton of fun, let's just say that's by a particularly idiosyncratic definition of fun.
Oh yeah, yeah. Your your mileage may vary. Um, yes, people remember facts better when facts are embedded in stories, and facts don't change mind, but stories do. So if you're in IT and you're trying to advance some kind of strategic change, strategic initiative, you got to have the right story to wrap around it, and that story's got to be uh, uh, embedded in action and person. So, you as a user in our IT environment, wake up one day, pick up your device, and see this. And if
Right.
if what your goal is the project that will put this on the phone in front of the person who's just rolled over, worried about something at work, you got to be able to tell those stories and then anchor everything you're asking for support for to the story and the facts embedded in that story. So that was my big takeaway: was the power of story is just as present, just as real, and just as crucial in the context of IT as it is in politics or religion or anything else.
Well, and I would agree with that and say, and furthermore, many years ago, I read something that stuck with me because, complete side note, and then a side note on a side note kind of thing. There's kind of a fun party game you can play, which is to ask everybody what their first memory is. And what you'll find if you ask enough people is number one, the average age of first memory is usually around 3. Some people will say 3 years. Some people will say, oh, I can remember when I was 18 months old. Some people will only remember when they were 5. The point of the game, and I'm not sure it's true, but it's kind of fun, is that supposedly your very first memory ha- gives your fundamental psychological stance towards the world. So if it's happy and you're exploring, that's one thing. If you're defensive, that's something else, et cetera, et cetera. It's a fun game to play. Try it, see what you think. But the thing that stuck with me is that when you go looking at the research in this, it turns out that the average age of first memory really is about 3. And the reason for that is because that's the point at which kids can begin to create narrative in their minds. If you have kids, you probably noticed that they may like you to tell them a story when they're 18 months old or 2 years old, but they're mostly just listening to your voice and the words. By the time they're 3, they really actually understand and they have a narrative, and they get mad if you try to change the story's endings. But what that tells us is that storytelling is foundational for the formation of memories. So, like John, when you were saying facts don't change minds, people don't even remember facts unless there's a narrative in context organizing those facts. And realizing that that's just inherent in human beings suddenly makes you rethink how you tell stories, how you communicate science and technology, because we're all trained through 10, 12, 15 years of training to tell a mathematical or scientific story by laying the groundwork. If X, then Y. If Y, then Z. Here's the situation. And by the time you get to the actual point of whatever it was you were going to say, only the people with serious discipline have followed you to that point, which is why I think in a lot of cases, math and science and engineering is considered so difficult, because you have to go through all this muck to get to the really interesting findings. But that's the wrong way to communicate anything to, say, senior executives. If you're trying to do something new and interesting, put it in the context of the capability it's going to give the company or the users, and start with that. And then circle back and say, this is why we haven't already done it. And here's why I need money and resources to go do this thing and make this vision possible. And ground that, John, as you were saying, in the actual human experience. Because as much as we like to say, oh, we're not people, that's why we didn't, that's not why we would go into science or engineering. It turns out that the people we're trying to influence usually are. So yeah, that I think was fantastic. So I guess one of the questions here is, what's the story around this project?
Streamline your IT infrastructure by switching to a cloud-native print solution. You'll reduce infrastructure by eliminating print servers, get front-end and back-end print management. You'll be bridging the gap between automation, document management, and print. You'll secure your data end-to-end with native integrations and enjoy a zero-trust-enabled environment. Start a free 30-day trial by going to printerlogic.com/packet pushers. Oh, it also integrates easily with EMR and ERP solutions. Plus, a simplified scanning solution is included. You can automate capabilities, create no-code forms and workflows in the same admin account, have full visibility, and reduce print tickets by 90%. Start that free 30-day trial by going to printerlogic.com/packet pushers.
Exactly. And one cool thing about the DevOps movement always to me was that it was grounded in stories. It was grounded in the user story.
Epic, yes.
The epic, exactly. And I always thought that was a tremendous way to try and pull people together, keep them focused on the goal. Now, the fact that those goals were bitten off in 6-week to 1-week chunks, okay. But still, I think the idea of using story to focus, it sticks. I had other sessions that I was very interested in, though, too. I mean, that was certainly the one that had the to me, the most unexpected importance for folks in IT. But we had some actual IT focused sessions too that I thought were really fascinating. A lot of sessions touching on one aspect or another of AI. And, what we had was one speaker saying, if you want to get from AI to AGI, AIs at the data model level need to understand time in a way that they fundamentally don't right now. And we can go into a lot of detail on that. Another was saying, if you want AGIs that are capable of working a multi-purpose, general purpose robot, AIs also need to have an understanding of space that they don't currently have. And then actually, mostly from a session with you, they also need a better sensorium if they're going to achieve true general intelligence. So time, space, and better senses necessary to make that leap from AI to AGI.
Yeah, I mean, the How to Train Your Robot session, that was by a professor called Dinesh Jayaraman at the University of Pennsylvania Engineering Lab. What I loved about that was he kicked off with the whole philosophy, which is the Cartesian mind-body split, also known as the brain in a vat, which, if you're at all familiar with neuroscience over the 20th and 21st century, the question is, if we took your brain and plopped it into a bell jar and like somehow kept it alive, would you be you? And long story short, the answer is no, because there are two things that are fundamentally missing. One is all the processing that your body actually does. And so if you study, for example, eyes or ears, you realize that the nerves in those organs, before they ever hit your brain, are doing huge amounts of thinking, much more than you ever expected. And the second is, John, what you were saying, which is that sensorium, you need feedback from the physical universe to create intelligence in the most fundamental way, at least general intelligence that goes beyond the idea of an algorithm that works to a certain degree in certain scenarios. So basically, you need AI plus feedback from the physical world to begin getting to that general intelligence. And that kind of touched off a book I had read recently called, and it's definitely scores for one of the best titles ever, Fire, Women, and Dangerous Things, by a guy named George Lakoff or Lakoff. I don't actually know how to say it.
Lakoff, I think.
Okay. It's an old book. It was from the 80s, but the guy had actually pulled the title from an Australian Aboriginal language in which there were 4 categories of things. Like everything in the universe could be organized into 4 categories. And one of the categories was fire, women, and dangerous things. And essentially, what the Aboriginal categories had was there's a first category that is like men, water, certain kinds of water like rain. The second category was the fire, women, and dangerous things. And there were 2 more. The underlying principle of fire, women, and dangerous things is unpredictability, which is actually kind of funny. And what's cool is that these categories actually carried the language into the 21st century because they could continue to sort things into those categories. And the categories, if you want to think about it this way, are sort of like gendering in, say, European languages. So most European languages, exclusive of English, have gendered words. So a table may be female, but a chair is male or whatever. And when you first learn them, you're like, where the heck did this come from? This idea that there's an actual gender to non-gendered things. And slowly you begin to intuit why a constellation of characteristics creates a category, and it's not logical. And that's actually, it's not logical, but it makes sense to humans. And that's where that circling back to that issue of feedback comes in, because in order to create categories, you need feedback. So you get enough sensory data to create a category that is not necessarily logically a category, but is functionally a useful category. And that's why AI struggles. And one of the things I loved about How to Train Your Robot was it zeroed in on exactly that problem and talked about the fact that giving the big challenge in helping robots move and take action is giving them enough sensory feedback that they could begin forming these categories. So they could look at a drawer and a cupboard and realize one of them pulls out and one of them swings out, and make that decision autonomously, as opposed to having been trained, go here, pull this thing because it's a drawer. And one of the things they looked at was whether you can train robots using YouTube videos. And the answer is yes. So it's absolutely fascinating. And I just loved how it pulled together all these disparate pieces of, what comprises intelligence above and beyond the algorithmic definition, which we're all kind of familiar with. So that was kind of my big takeaway.
I would say that Joshua Vogelstein's session on teaching AI to understand time was just as fascinating to me as that one was to you, because I hadn't truly appreciated the fact that one of the underlying basic assumptions built into data modeling for AI has been that the data stream is, quote, IID, independently and identically distributed, which basically means that the past and the future look the same, and that what you as the AI do won't affect what you as the AI see in the future. So it is fundamentally flawed in this way. And it is this fundamental flaw in how they're designed that makes them really bad at some things, like producing a random series of coin flip values. He pointed out how again and again, different models, huge LLMs, would fail miserably at this. And that if you just add to the basic understanding built into the data model conceptually, the idea that the future doesn't look like the past and that things you do can have an effect on what you see coming after, you can quickly make AI models that are very good at things like understanding sequences of coin flips or understanding trending in flu data, which, or COVID data, which AIs were very bad at when they were put to the task back in the last pandemic. He says, knocking on wood, hoping that there's not a next pandemic anytime soon. But he said he was able to show radical improvements in the performance of these LLMs when they were shifted from simple data modeling and learning to prospective learning. The idea that the model training process is going to select a hypothesis that is probably approximately correct going into the future, that it will minimize the error over time as well as in the moment. That was just full of a whole bunch of beautiful small learnings, like the fundamental principle of being alive is that you have to look for something to eat before you die.
That was, I remember when he said that. And the point, if you're listening, is, well, yes, I usually feel that way. But the point is that almost every organism has to somehow figure out, I need food before I die of starvation. So that time sequencing really matters, because if you die of starvation first and then start looking for food, it doesn't work.
Yeah. And he was able to show that adding this foundation of time to the modeling embedded in the AI, even simple perspective algorithms, looking forward and backwards and seeing the difference, can solve simple perspective problems that fancy existing LLMs utterly fail at. And that was for me a hugely important takeaway, and especially important for folks who are considering using LLMs in business contexts where the past and the future are not going to look the same, because you're looking to the AI for advice about what to do in the future in some fashion. So,
and
I think this
John,
is an important takeaway.
Yeah. And I think, John, that highlight is actually critical, because if you're looking for the AI to make recommendations about a future that you hope will be different from the past, we will have more sales, we will have different customers, whatever it is. I think the very basic takeaway is most AIs are incredibly bad at that, which is not the normal. We all were like wowed when we saw Google making predictions about flu even before the pandemic. And we're like, ooh, AI is really powerful. Google will tell you where the next flu center, hot center will be. And it turns out when you compare that data to what actually happens, it's horrible at it. For exactly that reason, because the current algorithms don't include this understanding of time and the notion that the future may be different from the past.
It didn't even do as well as the really stupid algorithm of tomorrow will look very much like today.
Right.
It couldn't even do as well as that. I think that the takeaway there is huge, important across industries, and something that needs to be on everybody's mind as they think about how they're going to use AI. Same would apply using it in a cybersecurity context. It matters whether the compromise has already succeeded as to what I do next about it. So that was my big takeaway. Oh, and that was Joshua Vogelstein at the Johns Hopkins University. That's where he is based.
I think was a great point, because I'm sure anybody listening that's been as inspired as we are is going, who are those people again? So just to recap briefly, that was, I think we started with Luke Becker, who's at Johns Hopkins Applied Physics Lab. That was the Dragonfly Mission Assurance. Then that was Aaron Bowe, who is a Canadian science fiction writer who was formerly with the Perimeter Institute, which is a quantum physics institute in Canada. Then there was Dinesh Jayaraman, who is at the UPenn Engineering School. And then Josh Vogelstein, Jovo anyway, is what he goes by, at Johns Hopkins University. So those are the folks that we were kind of blew our minds above and beyond all the other folks there. We don't, couldn't take the entire cover the entire conference because we'd have to have a 2.5 day long podcast, which probably most people would not listen to.
Oh, but I
So,
got to get two more in. Okay, so these are the ones that were just
okay.
personally fascinating to me. One was Jeffrey Litt, who works at Ink and Switch Labs, where they're developing what they call malleable software. The idea that you should be able to edit the software on the fly in the same way you would edit the content you're generating with the software. And anybody who goes far enough back in the IT space, like I do, remembers
say with some sadness,
either learning or envying the folks who took the time to learn enough Lisp programming to modify the functions of the Emacs editor on the fly. Like you could build functions into it if you were willing to. And I did, and it was cool. And, ongoing things like spreadsheets let you do this as well. You write macros, you add functions to the tool while you use the tool. Ink and Switch is dedicated to the idea that a lot more software should be like that the software you get out of the box should be like opening up a kitchen door, not like walking into a food court where your choices are limited and nothing is quite what you want. So I thought that was pretty cool. And the whole session on nanomaterials for photo batteries from Susanna Thon, also at Johns Hopkins, wicked interesting stuff.
That was interesting. And yeah. I mean, one of the things she talked about was things like solar panels that can be painted onto things. So using quantum dots as the core component of the solar panels. And I'm remembering just doing that one by memory because it was so interesting. So yeah, those are all great folks. It was mind blowing. And I think we learned a lot. And it's, as always, I think we picked up a lot of great questions to ask because, as we all know, it's all about the questions. So with that, I think we've come to the end of the session, the end of the episode. Thanks for joining us today. If you've got feedback or follow up or want to know more about any of this or want, have examples of scientists or researchers or storytellers who've blown your mind, we'd love to hear you about it. Send a message to packetpushers.net/follow-up. And you'll also find there the Network Break podcast, which helps you stay current on the latest tech news, and a whole lot more things like tech and new networking podcasts or newsletters, a job board, all sorts of fun stuff. And if you want to talk to John or me, you can reach us at nemertes.com. That's NEMERTES.com. N like Nancy, EM like Mary, nemertes.com. We look forward to hearing from you.